So I'm Renuka Narkani. As Nari said, I'm the Chief Product Officer at Aryaka, and excited to be here. This is actually my first security field day. Last time you were here was for the networking field day, and of course, very, very excited to share some of the things that Nati explained and shared what we are doing. For me, the most important piece is I'm told that this is a technical audience, so I'm going to completely indulge and take this opportunity to, really get into the architecture, the platform, and really get into the nuts and the bolts of how we are executing and how we are bringing to life what I call the vision of SASE, right? So before that, just a quick intro on my personal background. Before joining Aryaka, I was CTO security at F5. And before that, I spent almost a couple of decades trying to build different kinds of security technologies. And in fact, I take a lot of pride in the fact that I was pretty much a 1.0 in security, always tried to build the latest and the greatest and try to solve the newest problems in the security industry. And my career also evolved from, really pretty much on the network security side, but I've kind of touched every single technology. And I'm really excited about how the industry is converging, how there are all these different trends and ability to really do the right thing with building security and networking together with SASE as a trend, right? So this, in a nutshell, is what Aryaka has built. And as Natty was mentioning, this is something that we have built over 15 years. This is not something which just, we started building it and were able to deliver it in a year or so. So at the very, very foundation, what we are as a company is we have a very robust networking layer. And I think this is the foundational technology for SASE. So when you say, I want to integrate networking and security, one of the challenges that I always had when I was building security products is people would not let me put the security products in the network. So you may have best security technologies, you may have built like some amazing, technological things to find from a security perspective, but unless you can actually be in the traffic and do the enforcement, nothing else matters. So with Aryaka, the founder's vision was to have a very robust network and have the best performance, low latency, zero packet loss, global network architecture. And that is what we started building back in the day. And now what we are doing is so as a networking layer, we in fact have very, very sophisticated connectivity. We actually do compression, deduplication, all the WAN optimization, and all of those details that we shared in the last networking field day. We actually had a demo and we showed all of those capabilities. On top of that, what we did was we built security controls. So as you can imagine, there are only so many things you can do from a security enforcement point. You can actually drop the packets, you can do reset of connections, you can do redirection, you can do black holing. Like there's only finite kind of things that you can do. And if you are actually the network layer, if you are actually the plumbing, and you can actually look at every single packet that comes to you, the amount of things that you can do is like limitless, right? So from the security point of view, I think that there are all these technology names, like we had next generation firewalls, we had SWG, CASB, and all of these things, at the end of the day, what they really do is three things. One is access control. I want to make sure I know where the traffic is coming from, where it is going. So if you look at this, there are headquarters, there are branch offices, and there are remote users, and they're going to different places. And as we all know, applications are, they could be in the cloud, they could be SaaS, they are in the data center, or users could be going to the internet, right? So there are only so many sources and so many places that they can go to. And there are three things that you do. One is like access control. I want to make sure that the right people have the right access to right applications, no matter where they are going. The second thing is threat protection. We want to make sure that all the assets are protected, and all kinds of attacks, whether they are layer 3 attacks, whether they are more sophisticated application layer attacks, throughout the spectrum, we want to make sure that there is threat protection. And then the third thing is data exfiltration detection and data leakage prevention, which is to make sure that anything that is sensitive is not exfiltrated, right? So with that mindset, what we built is this unified SASE as a service. And one of my favorite things is we say, get it all. What it means is, like I mentioned, throughout my career, when I was selling security products, it was always a compromise between performance and security. Are you going to get in my way? Are you going to break my business critical applications? That was always a trade-off customers had to do. And then on the other side, there was always a trade-off when I was, for example, when I was at VMware trying to build virtualization security. And it was always like agility, like change management, how many approval cycles, like how do I simplify the process? So there's always this, simplicity and agility trade-off, performance and security trade-off. And that's what we think we have solved, which is we actually give customers everything, which is they don't have to do a trade-off between performance, agility, security, and simplicity, right? Now, from one of the side effects of this conversation is once you have this networking layer and all the security controls combined, one of the side effects you get is observability. We all know everybody loves AI, everybody talks about AI, but for you to do AI, what you really need is the information on which you can process. And that's really where, because all of these things go through our backbone, and we're going to talk about some of these things in details in a second, but we have access to all the flow information, all the payloads of different protocols. We have instrumentation built in, and we're going to focus on some of these things as we go through. Great. So let's double click what we mean by this. So these are the 4 components of Unified SASE as a service. At the core is our Aryaka Zero Trust WAN. Now, the reason we call it Zero Trust WAN is because you cannot get on our backbone or our WAN infrastructure unless we know who you are. So there is an implicit zero trust concept because we provide global connectivity for users trying to go to applications, and you cannot get onto our network unless we know who you are. Okay. Then we're going to talk about OnePass architecture. I'm going to spend probably majority of my time discussing the architecture and why it is important the way we have done it. Because a lot of these things, the technologies, access control, threat protection, data leakage prevention, have been around for more than a couple of decades. It's not that we don't know how to do security. It's not that there is no security technologies available. The problem you want to solve for is how do you make them enforceable and how do you actually make them effective? Effective security can only be done if it's enforceable. And that's where the SASE magic comes into picture. We have integrated multiple services. We're going to walk through some of these. And then last but not the least, sometimes customers know what they want. Sometimes they know exactly what the problems are, but there is a skill set shortage. They cannot have skilled people. Sometimes there's budget. They cannot have all of these things deployed in all the remote locations and so on, right? So this is where Aryaka really shines because we hold customers' hand through this SASE journey, and we actually help them deploy the right kind of controls. We help them in the process of designing with giving them, what are the best practices, as well as helping them manage it. Okay, so we're going to talk about that in a second.
I have a question, just based on that last slide, the Zero Trust WAN. You guys own or lease or run your own backbone as a WAN, or are you using, internet as transport and doing a WAN overlay?
So actually, that's a very good question. We have our own backbone. And when I say our own, we actually have the hardware which sits in the colos. I have a slide later, we're going to double click on it, but we own our own hardware in the colos. We also own the, between the intercontinents, when there are fiber connectivity, we actually have guaranteed bandwidth that's available to Aryaka customers. As an example, like right now, there was a fiber cut in Red Sea, and it impacted everybody, right? So typically what happens is when these kinds of things, I call them internet variabilities, there could be a massive DDoS attack, there could be fiber cuts, there could be cyber warfare, name it, right? And they have disruption at a global level. And even the largest of the largest providers, their customers suffer the latency and slowness because of the internet access. In case of Aryaka, because we own our hardware and also that bandwidth, our customers have zero impact. Nobody even blinks. They don't even know about it because they fall back on the secondary. And on the secondary, they have that same guaranteed bandwidth that they have from Aryaka. So when we say, by the way, we run at like, so network connectivity is our core business. That's basically, we started solving those problems, right? So we run this entire global backbone with like 5 nines availability. We have 100% redundant links with 100% redundant availability. So there are places where we do, I'll talk more about multi-tenancy and so on and so forth. But one thing we do not share among the customers is like the bandwidth. Like if I tell you I'm giving you this bandwidth, I have it for you, even if there is an event like this Fabric. Okay? And this is something we always love to talk about, but thanks for bringing that up. Any other comments before I move forward? So I'm going to quickly go through some of these things, and then I'm going to spend more time on the architecture piece. But what does this mean? Like, what are the basic things, right? So it is low latency end to end. I started this conversation saying that the founder's vision was to have this low latency, zero packet loss. And the reason for bad user experience is not necessarily latency, it's actually packet drops, because it causes retransmissions and it actually changes the user experience of the application itself, right? So these are some of the problems that we have solved. Everything is cloud delivered. So back in the day, we were born in the cloud as a service. Everything is architected, as you see in the later slides. Everything is cloud delivered as a services, and we can serve in. We today have customers, and we serve in 100+ countries, which is also really very important, because when you try to do all these things together, you probably have personnel who can do it in like a few locations that that customers have, but trying to do it at a global level, we can actually bring up any site anywhere in the world for you and give you the same unified SASE as a service that you have in your most sensitive data center or in your headquarters, right? So having uniform policies and applying them consistently is what is the core value that Aryaka brings to the table. So these are the like three main components. As we mentioned, we own all our POPs. So the components of our service are really the cloud-based enforcement. I'm going to talk about this a little bit more, but one of the things is most SSE by design are the architecture is that you take all the traffic to the cloud and you process it. Okay, and this is where if I knew what traffic to bring, if I knew like all the bad actors, like what they're using, which port protocols they're using, my life would be so much easier. So the challenge with most security, and I was like part of these conversations before when I was selling security products, is bring me the traffic and I'll do magic. Right? I'll give you the best security once you bring me the traffic. The question is, how do you bring the traffic in the first place? Who's going to pay for the bandwidth? Who's going to pay for overhauling all these connections of all port protocols and bring them to the cloud? Who's going to do that, right? So one of the big differentiators is we actually process security closer to the source. So Aryaka Edge CPE devices, we call them ANAP. You'll see that in the later slides as well. It's capable of enforcing all the three things that I talked about: access control, threat protection, and data leakage prevention. It is at the edge of the branch in the CPE. We can do the entire processing. You don't need to take the traffic to the cloud as a SSC or a classic SASE. Okay. And then the third piece is when remote users are accessing these applications, they hit the nearest POP, and there are two very different benefits to this. One is, as we all know, with COVID, everybody was working from home. But before that, remote users and IPsec VPN was not that common. So if you're sick, if there's a special reason, you were using that. But when the remote access became prevalent, it became very important from the employee productivity perspective that the performance of that remote access was acceptable. Again, same experience, like user experience. When I'm trying to go to the applications, I'm crawling all the way over the internet. My workloads are somewhere in Amazon West, in the cloud. By the time it gets there, the experience is really bad, right? So with Aryaka's private access, there are two very clear benefits. Of course, it's secure access, but the second thing is accelerated performance. So what we say is your users can be anywhere in the world. As soon as you get on our global private backbone, it's a LAN-like experience on the WAN, right? So these are the three main service components that actually help us. Now, this is what we talked a second ago, and these are all the different locations. One of the things I would like to point out is when we do connectivity to the cloud providers, we have a direct connect. In a lot of places, we are in the same colo facilities where they are. Okay. So that also brings another conversation, which is when you are going to the cloud workloads, when your users are remote all over different parts of the globe, the user experience is again accelerated. It's almost like you're in the in the US West, and your workloads are also in US West. But you could be coming from Brazil, you could be coming from China, you could be coming from any different country, right? So that's basically how we have architected that.
I'm sorry, could you go back a slide?
Sure.
Can I ask questions? So when you talked earlier about reliability and backup and all of those things, how is that, when I look at those connections, how are you providing that? If one of those sites was to go down, for instance.
So we have multiple layers of high availability built in. So when you say the site goes down, what problem?
Let me chime in. So all our POPs, what you see here are the dots on the global map are POPs.
Okay.
So these are physical cages inside a colo facility with Aryaka equipment in there, networking and connectivity. We have wavelengths that interconnect these POPs in a region. They are fully meshed. So let's say you have a link that's going from Dallas to Seattle that's down. That traffic gets rerouted through another link. And every POP has links from different providers so that we have that redundancy, so that it's not just dependent on one provider. So
yeah, so within our POPs, it's a fully mesh network. We can do rerouting at any point in time. We also have from the site when the traffic comes in, we have high availability with 2 ANAPs. We have an ANAP bypass. So there are multiple layers of protection that are built in terms of different failures. And even when we talked about like fiber cuts and so on, right, we can reroute it to a different link.
And can I ask a clarification, just follow up? The lines on this chart, what are they meant to be illustrating? You've got the connections between these locations.
These are the connectivity between our own network.
In your own network.
Yeah. Yes. So this is actually, think of this as like a internet highway that that Natty was mentioning, which is so this is basically the network part of it. And then on that internet highway, we can do more things like checkpoints and like cameras and so on and so forth. So this is our backbone. This is our global network on which our customer traffic travels.
Our customers' networks connect to the closest Aryaka POP.
Right.
So whether you're a remote user or a branch, you connect to the closest Aryaka POP, and then you write this information superhighway.
And I was going to say,
private.
How many pops can it hit? So like you were saying, everything it's fully meshed. So if it hits one network and it goes down and then it reroutes it, how many times will it do? It'll just keep hitting whatever's closest within the vicinity.
It just goes to the closest. So the routing and all that configuration on the CPE device is also something. I mean, that's where you actually say where the traffic goes and how that happens.
Okay.
So it doesn't randomly go to any POP. That's not how things work. It goes to the closest POP, and that is also configured.
Got you. Okay.
Right, both on the client side as well as on the CPE side.
Right.
Right.
Okay.
Yeah, great questions. So now I'm going to spend a little bit more time. We're going to go to the next level of detail. I'm going to double click on this a little bit more. Okay. So one of the things I explained earlier is you could have the best security processing, but how do you make sure it's enforced? And this is where what we have built is distributed data plane. And all the features and the capabilities that I talked about in terms of networking as well as security are enforced with ANAPs, which is our CPE device, as well as in the POPs. So we do the full network processing, full security processing, as well as all the acceleration and all that. And it can be done at both places. One is the CPE, and the other one is in the POP. Okay, and if you think about this, when you say security processing, what are we talking about? We are talking about decrypting SSL. Okay, we are opening up HTTPS traffic. We are decrypting. We are actually looking at the payloads. We are trying to do intrusion prevention, signature matches, all kinds of stuff. Right now, think about it from a perspective of we are a cloud-born company. We have hundreds of customers globally distributed, and each of our customers has hundreds of sites. Now, when you say, I want to do SSL decryption, how do you know which SSL key to send where? How do you know where am I going to do the enforcement, right? So the fact that it is done at a CPE and at a POP, it's not just a like a trivial thing saying that, hey, we do it at both the places. The more important conversation is how do we actually manage the policies? How do we have consistent policies that can be enforced everywhere, right? And that is where our unified control plane comes into picture. Again, goes back to we were born in the cloud. We were not an appliance that somebody had a full stack of data plane, control plane, management plane that was then broken into making cloud services. Okay.
Renuka, I have a real quick question. You said that you guys are doing SSL decrypt to do policy enforcement, things like that. Are you forcing TLS 1.2 to do that, or can you decrypt TLS 1.3?
Anu, would you?
Yeah. So right now we bypass TLS 1.3. We are not there yet. We're working on it.
Okay.
Yeah. So if we are unable to, we will bypass.
So you won't try to decrypt at all?
No.
Okay.
Yeah.
Because I know that TLS 1.3 has protections built in to prevent that very thing.
Yeah.
So that's why a lot of companies will force 1.2 to provide for that decrypt. So you're just saying,
At this time, we are bypassing it.
Okay.
Yeah.
But that's only if the client is
Forcing.
1.3 only, right?
Correct. Yes. Otherwise, we'll down negotiate and then we'll work on it.
Gee, that's a very interesting point, Tom, because see, one of the things is we are a networking company. So essentially making the applications available for us is a priority.
Mhm.
So what happens is there are a lot of for other reasons you have to bypass the SSL, as you know, for privacy and so on and so forth, right? So we can do all of that. But the good part about this conversation is when there are things like this, when there is like a new protocol, there is like, we have not built it, we as a networking vendor have the opportunity to do traffic steering, traffic handling in the right way, which is another very unique thing. So in the past, when I was building security products, the security products would typically break if something changes at the network layer. So that's like a very big distinction. And it's a good thing that you brought it up because I do want to make sure that one of the things we do is we always make sure that you have connectivity. And as a network vendor, we can do different kinds of traffic steering. We'll talk about like, service chaining and those kinds of things as well, right? So that is like the benefit, which is we get 100% of the traffic. And then we do different kinds of processing based on what's needed and what the customer needs are, what use cases are. So on that, the control plane actually has all the networking configuration. You see traffic optimization. So this is, again, there is sometimes there's special treatments in terms of QoS and WAN optimization. We do like deduplication. There are certain protocols which are a certain traffic that is more suitable for it. Sometimes they don't want it. So we can do all kinds of network layer configurations as well as security configurations for the firewall, SWIG, IPS, anti-malware. Even within IPS, we'll talk about it, which is there are different kinds of things you look for. Before you do encryption, there are different kinds of things you look for after you do encryption. So all of these things are managed and controlled by our unified control plane. Okay. So the fact that we can actually do the distributed data plane is because all the magic and all the things that we have built on the unified control plane side of things, right? And then the most important piece is how do you make this friendly for the customer to use and configure, okay? So there are two parts to this conversation. We have a co-managed management plane, which is we can actually manage configuration for our customers. We can have customers manage the configuration by themselves. And the interesting conversation here is when you combine networking and security, there are always different groups in the organization, in the customer. There are always a security team, a networking team, and there are different preferences in terms of who. Sometimes they want to outsource it, sometimes they want to manage it themselves. So the way we designed and the way we architected our solution is we can allow the customer to be on any spectrum of that, from being self-service completely to be fully managed. So that's why we call it co-managed management plane. So these things together is basically what we call as our OnePass architecture, which allows this performance, agility, security, and simplicity that we talked about. Let me pause and see if there's any questions, any comments on this.
Yeah, so I guess I just have a quick question. I know that you had mentioned that I guess you guys have a managed services offering. So is that where kind of that co-managed comes in, where you'll come in and step in for the customer, say if I need specific things, or I guess tell me more about that.
Yeah, see, typically what happens is customers are like, I have a new factory coming up somewhere, I have a mine, sometimes they are, changing locations, and they want to have uninterrupted network connectivity at that site, at that location. And they are in the countries where they do not know who the service providers are, they do not understand the currency, the contracts, and all of that, right? So they say, hey, Aryaka, get me like SD-WAN, get me connected. I need all of these things, right? Now, they may have a security team that wants to have specific configuration for a variety of compliance reasons, for different geography needs, and so on and so forth. And then the security team can come in and they can actually do the security configuration by themselves.
Okay.
Right. So it's a very interesting dynamic. I find it very exciting, like how even customers are kind of like figuring things out as we go. Because the minute you start combining networking and security, you are not only combining the technological aspects of it, you also have to make sure that the company's processes and operational aspects are taken care of. Like, who is going to do the change approval? Like, who is responsible when I make a firewall change? How do I make sure that I go through the review cycle? How do I make sure that all these things are implemented? So that is where we have done very interesting things. We have ServiceNow ticketing integration, and again, because we have been in this same business for 15 years, we have actually done all these different variations, and that's why we built this platform which has ability to do both.
So you're kind of bridging the gap then between managed services and working on a team where you guys can kind of integrate really fully then.
That's a very good way of putting it. Yes,
Yeah.
that's exactly right.
Very nice.
It's a very good way of
Because
putting
nobody wants to mess around with the BGP config. It's working, don't touch it.
Yes, I mean, I think that's where the power of combining these two comes into play. But at the same time, making it easy to adopt, making it easy to implement also is important, right?
Thank you.
If I can ask one more question as well. Since you guys are owning and running your own backbone, and it looks like you guys have CPE devices, some sort of edge appliance that sits at the edge of the network. I think the value add for network traffic is to get it onto your backbone as soon as possible, right? Because you control it. But if I have multiple POPs, am I allowed to go from multiple edges? Am I allowed to go from my edge to another edge without going to your backbone first? Can I cross whatever transport I'm using, whatever local ISP I'm using?
Actually, we do have a lot of these different configurations.
Yeah.
And it's very interesting because there are different reasons why customers want to do things. So sometimes they would just want a site-to-site VPN, as we call it, which goes from one CPE to the other CPE, right? They don't want to get on the backbone. The thing I talked about, which with the distributed data plane, one of the biggest benefits is that you can do internet breakout at the branch. So if you remember back in the day, people did U-hauling, U-pinning. They took all the traffic to some place, and that place did the processing and then sent it out to the internet. Now, more and more people want to do branch internet breakouts, as an example, right? So there are many different kinds of configuration. In fact, if you just look at the network layer, the kinds of things like people have in their network, it's just amazing. Like, there is so many variations in terms of how people want to move traffic between their sites and so on. So we have done a lot of these things because that's something we like. That's like our, we do that for a living.
So I'm curious to know which of these capabilities, as you move through your slides, are available. And I don't know if your architecture is this way. Of course, we will learn as you go through. But which of these capabilities are offered only by you when we put the traffic on your backbone, and which of these capabilities are at our edges, whatever edges that you guys provide, whatever appliances we have at the edge?
So Aryaka appliances or Aryaka appliances? Yeah, so today, everything that I'm talking about is available, when we say distributed data plane, is available on the CPE apps, which is the edge appliances, and everything is available in the cloud as well. Like everything that I'm mentioning today is available in both the places, which is why we call it distributed data plane, including the thing I mentioned, which is like SSL decryption and making sure that you handle the right policy.
Yeah, that was
So the software stack that runs.
Anu, do you want to add anything?
Yeah. So I think that's what Natty was also going to say. The software stack that runs on our POP also runs on the ANAP, the ANAP device. The ANAP device not only connects to the POP, but can connect to another ANAP device at a different site. It can connect to a third party. Let's say you have something that's not connected via the ANAP, so some other third-party location that you want to connect to. Let's say you haven't migrated to Aryaka yet, you currently have another vendor, cloud security vendor, that's doing security web gateway. The ANAP can connect to that, and it can also locally break out. So you have multiple paths from the ANAP to wherever your destination is, and you can write policies on the ANAP to say, I have application that does not need to use this dedicated core that Aryaka provides. It's cheaper to run it over the internet. I can just break out the application, say, send it via my internet tunnel that goes to my destination.
Yeah.
Or this particular application does much better with Aryaka. Let's bring on the compression, the deduplication, the load balancing, the dejittering. Let's put it on Aryaka. So you can pick and choose what application rides what network to get to its destination. And you can control that centrally, like for the whole of your organization, or site by site as you need it.
Yeah, that's
Yeah.
perfect. That's exactly what I was asking.
Yeah.
Okay.
And-
And extend that a little bit and talk a little bit about the management frame. Is in support of that, can customers also pull the management information into their own internal management systems?
Oh, absolutely.
So they've got the whole piece, not just the data, the control, but also the management aspect.
Yeah. So we have SIM integrations today where we can send all the information. What, if I understand you correctly, we don't allow other people to configure our devices or our configurations. So that is through our portal only, right? But we do have ability to send out the configuration as well as the logs to other devices or to other systems that they may have. They may have like a CMDB or they may have like a SIM. So we can send our configs to that, but everything is controlled. And this is all like globally controlled. All the changes are made like almost in real time. So that is all done by our portal.
Gotcha.
Right? Okay, I'm gonna geek out a little bit more. Okay, so bear with me because I don't always get this opportunities. So every time I get a technical audience, I always like to indulge.
You're the right
So-
place for that. You're the right place for that.
So I'm not gonna go into too much details. If there's questions, I'll answer them. But why do we claim to be high performant data plane? We really need to double click on that, right? And the reason we do that is because a distributed policy enforcement, security closer to the source. When I was describing typically SSE and SASE, they take all the traffic from wherever it is to the cloud processing, and then always you have to make choices. I take like certain port protocols, and then I take certain, there is always a classifier of what traffic I want to process. And that really is, in our case, we say all the traffic, we will process it. And the reason we get better performance is because of the distributed aspect of it. I can do internet breakout. I can do all the processing locally. So my compute is distributed. I don't have to take everything in one place in my POP, in my cloud, and do everything in one place, right? So by design, the architecture by design is actually very high performant because of that. We talked about traffic steering options. This was the question that you had before, which is, I want to do different things to my traffic, and we can do many different things. We have a customer who wants to do security for SaaS applications by the SaaS vendor. They are like, I don't want networking people to touch my access control CASB. I want to do it in the SaaS directly with Microsoft Defender as an example, right? So we can do the traffic steering. The second piece is, this is actually very interesting. Like back in the day, actually, one of my first jobs was when I was in the CTO office at Cisco, and Cisco was not in security at that time. So they were trying to, they had acquired a couple of companies, and there was like a really very religious fight about, is proxy the right way of doing things, or is stateful inspection the right way of doing things? And this is when Checkpoint had just, come up with the stateful inspection as a concept, and they, in fact, I think trademarked that term and so on. But it was really like, how do I make the performance better? How do I get the performance better by, packet level and stateful inspection versus doing a full termination of a connection as a proxy, right? And back in the day, because we had compute limitations, as you saw, the industry kind of grew in the stateful inspection kind of a thing, and NGFW was all port protocol stateful inspection. And then there was a small subset, which was SWG, which is, I'm going to do full proxy only for certain port protocols, only for HTTP, HTTPS, SMTP, FTP, and so on, right? So there was a choice or a trade-off that has to be made, that was made. Now, what the beauty today we have is we don't have to make that trade-off for those choices, right? So the way Aryaka architecture is designed is we do full processing, we call it like run to completion model, where we do stateful inspection layer 3, layer 4, layer 7 piece. We do full proxy termination for specialized security handling for certain payload processing for web filtering, antivirus, and so on. And all of these things are actually managed by unified policy model, okay? So being able to do all this processing from start to end is actually the reason why we can in fact do it at this high performance and do it by design. We are built to do it that way, right? Then there's multi-tenancy concept. So multi-tenancy across hundreds of customers, the way we were built in cloud, born in cloud, and we share resources, but each of our customer has a separate process or containers that are used by that particular tenant. So there is no what I call as noisy neighbor issues. And this is very important because initially when I was at companies where we tried to build a cloud offering, and the biggest problem with the cloud offering was when you have multiple different customers, if one of them gets DDoS attack, everyone else in that same realm, whatever you want to call it, cluster and so on and so forth, is impacted, right? So in our case, we do multi-tenancy at scale. Within the same tenant, we actually have a scale out architecture. So one of the things security industry always was trying to solve for is performance with scale up architecture. The scale up architecture is I'm going to do hardware acceleration, I'm going to do extra processing, and this is all like now done in a slightly different way because instead of doing scale up, we do scale out. Okay, so these are some of the secret sauce, in the way we have built it for the data plane. On the control plane side of things, we had the luxury of designing the policy model from scratch to integrate networking and security. So what we did was we reuse all the policy objects. We use all the configuration. Like again, it's a start to end. I start creating policy. I create a policy for network, for all the networking services, and also for security services as needed. So a very important part is all the policy objects are shared. Policy management is easy. We also share intelligence across functions. So it makes it, again, easier to use. So we have similar libraries for DLP. So when you do DLP on SaaS applications, you call it CASB. When you do DLP on like data center, you call it like DLP technology. When you do it with for the public cloud traffic, you call it like CNAP or prediction for your cloud. But the technology underpinnings are identical, right? It's the same kind of libraries that you match for privacy, data, and so on and so forth. So a lot of this technologies and functions are shared. And the last point here is we have built-in instrumentation at the CPE and POP. So because we run the similar enforcement technology at both CPE and POP, we actually have ability to instrument right kind of information. And what we did by design was when we send a log message, we do it per session. You get everything, source, destination, payload information, what tools were hit, policy IDs that hit it. So there is a lot of information in that one log message. We don't create hundreds of logs and potentially even DDoS your SIM. Right? So some of those things we take care of as well. Any questions, comments on this? And then the last part is how we have built our management plane or the services that we talked about. So it can be self-managed, it can be Aryaka managed, or it can be co-managed. And when it comes to the delivery choices, our customers can use Aryaka's technology through and through. But there are occasions that we discussed earlier, use cases where customers want to have, they already have investments in other technologies, and they are like, hey, can I use like Microsoft Defender as an example for CASB? Can I use some other technologies? And because we have that flexibility of traffic steering that we touched upon earlier, we can actually do third party as well as native. Okay. So that is basically my last slide. So today, what we are going to do is we are going to show you a demo, which is going to be focused on the security capabilities. Last time when we were at the networking field day, we showed how the configuration on the networking side of things were for the different sites and so on. And today we're going to spend more time on the right side, which is what are the different, how do we create a policy, security policy, and we're going to show you a demo, which my colleague Anu is going to walk you through.